Okay, let's move on to section 3, which is going to be machine learning workflows. Now, before we answer the question, what is a machine learning workflow? Let's rewind a little bit. What exactly is machine learning? Machine learning is a subdiscipline of AI, or artificial intelligence, that's going to focus on the use of data and algorithms to gradually improve the accuracy of solving a particular problem. Now, the resulting code is going to consist of the algorithm or algorithms and the learned parameters, which is commonly going to be referred to as a trained model. So what exactly is a machine learning model? A machine learning model is a piece of code that can be written in just about any language, although Python appears to be the most popular choice right now, that a data scientist is going to make more intelligent by having it learn through training against data. So as you can imagine, a model will only be as good as the data, the training, tuning, and applicability to the original problem. For example, a model that uses stock market data to predict the weather sounds like an incredibly bad idea, no matter how big our data set or clever our algorithm is going to be. Meanwhile, a model that aims to predict the weather in a specific city 7 days from now that has access to 150 years of meteorological data is probably going to stand a better chance of giving a more reliable result. So what is a machine learning workflow then? When taking machine learning models from development to production, we're going to need some sort of logical workflow if we're going to stand any sort of chance of success. Now, this workflow is typically going to consist of several, but likely more iterative steps. And what we mean by iterative here is that depending on the results that we get at the end of each step, we may want to go back to a previous step and rethink our problem, our choice and framework, or algorithms, the quality of our data set, and or if the model has been sufficiently trained without it being overtrained and tuned. Okay, now that we have a little understanding about what a machine learning workflow is, what does a Kubeflow-centric machine learning workflow look like? We can really break it down into 2 phases. The first one is going to be the experimental phase, and the second one is going to be the production phase. Now, in the experimental phase, this is where we develop our model based on our initial assumptions. We then test and update the model iteratively to produce the results that we're looking for. In step number 1 is where we do our problem identification. In this step, we need to clearly identify exactly what the problem is that we're trying to solve with our workflow. For example, we may want to identify spam in incoming email or scan MRI images to find specific attributes that can aid in diagnosis, or analyze system and monitoring data to predict the mean time to failure of a system. In step 2, this is where we do our data acquisition and pre-processing and analysis. Now, this step can arguably make or break the usefulness of your machine learning workflow. Whether or not you'll get meaningful answers has everything to do with the data at your disposal. As any data scientist is going to tell you, just getting access to good data can be an adventure all on its own. Sure, there's the amount of data to consider, but we also want to think about the quality and the format of the data. For example, will analyzing a data set of 100,000 emails that were flagged as spam by users be sufficient? Due to the storage and compute resource constraints that I have to operate under, I can only train my models on low resolution images, even though I know that I can get more accurate results if I can get access to high resolution images. Can my model handle both structured and unstructured data, or do I have to normalize it in some way? What is the effect of excluding data that I can't operate on, even though I know it will be valuable to use in training? In general, the more data you have at your disposal, the better. The more relevant, accurate, consistent, and uniform the data is, and depending on the use case, if it also spans a large enough of a relevant epoch, the better the training runs are going to be. And in turn, the more satisfactory the solution to the problem you identified in step 1. Now in step 3, we're going to do our framework and algorithm selection. So at this point, we have a clear idea what our problem is and what problem we're trying to solve and the data that we're going to need to solve that particular problem. So this step is going to involve choosing a machine learning framework, settling in on the algorithms that we're going to need, and then coding up our models. So a machine learning framework can be any piece of software, API, or library that's going to let us develop our models easily without imposing the need for a deep understanding of the underlying algorithms that it supports. For example, things like TensorFlow or PyTorch and others. Some frameworks are going to lean towards generic use cases, while others are going to be very specific to particular use cases. In general, machine learning algorithms are going to fall into 3 broad categories. First, supervised learning. So for example, regression or random forest. Unsupervised learning, for example, a priori or k-means. And reinforcement learning, which is going to be things like Markov decision process. Note that the algorithms you decide on as necessary for your workflow may determine what framework you ultimately end up using. Why? Not all frameworks support all the algorithms employed in data science, so it's something to consider. Okay, so now in step 4, we're ready to train, validate, test, and tune our model. In this step, we're actually going to start training our model against our data set. And there are typically 3 iterations that we go through during this step. The first one is going to be the training set. So this is going to be the data that's going to be used to train our model. For example, in our spam example, let's just say we have 80,000 emails from a set of 100,000 emails that we know are spam. This is the data set that we're going to use as our training set, these 80,000 out of 100,000. In our validation set, this is going to be the data set that we're going to use to tune or to validate the outputs. For example, the remaining 20,000 emails from our set of 100,000 that we know are spam. And then finally, our test set. So this data set is going to be used to test the accuracy of our training and tuning. So for example, we'll get a brand new set of 50,000 emails that we know are spam, but the model is never trained or validated against to see how accurate our model is. Now, in step 5, which is not listed here, is the iteration process, right? So depending on the results, we may need to rethink the scope of our problem. The data set being used to train our models, or the framework selection, or the algorithms that we chose. We'll probably maybe even need some additional testing, some validation or tuning runs, right? This is really all going to depend on how the process has worked so far. We may also discover that we've overfitted or overtrained our models, right? This is going to be, it's not a closed loop system is what we want to get at here during the experimental phase, but will obviously take several iterations to get just right. Now we're ready to move into the production phase, which is shown here in the lower right. So we're done with experimentation. We're ready to get these models into production. And at a high level, there are a few typical steps that are going to be required to bring these models to production. And the first step is going to be the data transformation, right? So like we saw in the experimental phase, we once again need to transform our data into the required format for the model. In this case, we're working, however, with a production data set. So this is done so that the model is going to behave consistently during the training. And typically, this is going to be the same as we see up in step 2 in the experimental phase, but we might be dealing with a much bigger data set. For example, 100 million emails versus the original 100,000 emails that we talked about in the previous example. How we prep the data, however, should be identical if we want to get accurate results or similar results. Now, in step 2 of the production phase, this is where we're going to train the model. So it's similar to step 4 in the experimental phase, except we are training with a production data set. Now, in step 3, we want to serve our model. Now, here we're going to deploy the model into production. In our ongoing spam example that we've been using, this might mean operating on email as it shows up in real time or analyzing large sets of email once an hour in batch mode. Now, in step 4, here's where we monitor, tune, and retrain the model. So we obviously want to monitor our model in production and feed back any insights into the model, or back into the model, I should say, whether they be additional tuning opportunities, problems with the data, new data that becomes available, resourcing issues, etc., that we're going to be discovering while we're in production. Okay, and in this final slide of the machine learning workflow section, we wanted to take a different view of what a workflow looks like. And in this case, we're looking at it from the perspective of individuals and teams, right? So we've got all these different steps that we need to do within a workflow in order to go from a model that's on a laptop to something that's running in production that's accessible by many users or services running on a public cloud, for example. In order to kind of work through that development to production, there's going to be a lot of different individuals or teams within an organization that are going to have to get involved to make it successful. Over on the far left, right, when we talk about our data acquisition, data transformation, our model development, framework selection, algorithms, etc., this is going to be the purview of data engineers, DBAs, ETL engineers, data scientists, right? Then as we are ready to move these models into production, we're going to start having to deal with folks that primarily deal with infrastructure. So this is going to involve machine learning operations folks or DevOps, right? And then depending on our setup, we may need to then get involved with the security folks at our organization. And then finally, right, in a worst case scenario, let's just say our models are somehow biased, determined to be biased, or maybe they're unethical. Then we might have legal folks that get involved. So the thing that we all want to illustrate here is that machine learning workflows are inherently complex problems, machine learning workflows are inherently complex, right? Complex because the process is complex, complex because the software tends to be complex, and then complex because the number of teams and individuals within an organization that need to get involved also adds complexity to the situation.